Okay, in this figure here, we have PQRS, which is a rectangle, and QRT is a right-angled triangle with the side measuring 30 cm, 40 cm, and 50 cm. And the perimeter of the shaded part is 174 cm. So this is the perimeter of the shaded part. Okay, and it's 174 cm. So we are supposed to express the ratio of the area of the triangle to the area of the shaded part. Okay, so first of all, if QR is 50 cm, PS has to be 50 as well because it's a rectangle. So you can write down PS is equal to 50 cm, and PQ should be equal to RS, and we can let this length be X. Okay, next, the perimeter, right, of the shaded area, it will be X plus 30 plus 40 plus X plus 50, and this will give us 174 cm. So we solve this equation. We have 2x plus 120 is equal to 174. So 2x is equal to 54, which we can get by taking 174 minus 120, and x is equal to 27 cm. So you can just put it in 27 cm and 27 cm. Okay, so now we can find the area of the unshaded triangle, which is this right angle triangle. We can just take half times base times height. Okay, so that will be half times 30 times 40. We will get 600 cm squared. Okay, next we want to find what is the total area of the rectangle PQRS. So area of rectangle PQRS is equal to length times breadth, will be 50 times 27. So that will give us 1350 cm squared. And the area of the shaded part is just the area of the rectangle minus of the area of this triangle here. Okay, so the area of shaded part is equal to 1350 minus 600. We have 750 cm squared. So now if you want to find the ratio of the area of triangle to the area of the shaded part, that will be just simply 600 is to 750, and if we reduce it to the lowest term, we will get 4 is to 5. That's the answer. Okay, we have two rectangular tanks that are shown in the figure here. So they have different dimensions. So at first, tank A was empty, while 1/3 of tank B was filled with water. So tank B was 1/3 full initially. So both taps were turned on at the same time, and water from both taps flowed at the rate of 1.2 liters per minute. 1.2 liters, it is also 1200 cm cubed. So we want to find out how long did it take for the height of the water to be the same in both tanks. Okay, so first of all, we can find out how much water is there in tank B initially. Okay, so what we can do is this: volume of water in tank B, it is 1/3 of the entire volume of the tank. So it is 1/3 times length times breadth times height. Okay, so it is 50 times 20 times 36. This will give us 12,000 cm cube. Okay, so with this we can find out what is the height of the water. We just need to take the volume of the water divided by the base area. Okay, so initial height of water in B, it is 12,000 divided by 50 times 20. That will give us 12 cm. Okay, next, we know that when the tap is turned on, right, the water flow out at a rate of 1.2 liters, which is 1200 cm cube per minute. So as the water flow in, right, what is the rate of increase in the water level in each tank? So we can find out here. So in 1 minute, okay, we know that 1200 cm cube will flow into the tank. So what is the height increase in the water level? Okay, that will be the volume of added water, which is 1200 divided by the base area. Okay, so this is 60 times 10. So we get 2 cm. So that means in tank A, the water level is going to increase by 2 cm every minute. Okay, so how about in tank B? Okay, the height increase in water, it will be same thing, 1200 divided by the base area, which is 50 times 20. That will give us 1.2 cm. Okay, so now it's quite clear. Initially in tank B, there's a water level of 12 cm, and every minute the water level is going to rise by 1.2 cm. And for tank A, the water level is 0 initially, and every minute is going to rise by 2 cm. So how long will it take for the height of the water in both tanks to be the same? Okay, we can introduce a variable. Okay, we let the time taken for the height of water in both tanks to be the same, be t. Okay, so at time t, the height of water level at A is going to equal to the height of water level at B. Okay, so the height of water level at A will be just 2 cm every minute, so at time t it will be 2 times t. And whereas the height of water at B, initially it is 12 cm, and every minute it increases by 1.2, so it will be plus 1.2 times t. So we have 2t is equal to 12 plus 1.2t, So 0.8t is equal to 12. T is equal to 12 divided by 0.8. Okay, that will give us 15 minutes. Okay, we have ADEF, which is a rectangular cupboard with AF equal to 7 cm. 2 quarter circles have been cut out from it as shown. The remaining cupboard, which is the shaded part, has an area of 56 cm square. So we can just label this is 56 cm square, and this A, B, F and C, D, E, they are 2 quarter circle, so they are the same. So we can say that AB is 7 cm, CD is 7 cm, and DE is also 7 cm. Okay, so what we can do now, right, is that we can find out what is the area of 1 quarter circle. Okay, so it will be area of quarter circle. It is equal to 1 quarter times pi r square. So it is 1 quarter times 22 over 7 times 7 square. We will get 77 over 2 cm square. So now we want to find the area of both quarter circles. So the area of 2 quarter circles will be 77 over 2 times 2. That will be 77 cm square. Okay, next we can find the total area A, D, E, F. That will be just the area of the 2 quarter circles plus the area of the shaded part here. Okay, so area of rectangle A, D, E, F, it will be 77 plus 56. That will give us 133 cm square. Okay, with this, right, we know that AD times 7, which is the width, is equal to the area of the triangle. Okay, so AD times the breadth, which is 7, is equal to the area of the rectangle, which is 133. So we know that AD in this case is equal to 133 divided by 7. That will give us 19 cm. So this entire length here is 19 cm. So to find the length of BC, right, we can just take 19 minus 7 minus another 7. That will give us 5 cm. So the answer here is 5 cm. Okay, in this figure we have a square ABCD and it's made up of 2 parts, X and Y. The part X is formed by a semicircle and the line AB. And the perimeter of X is 36 cm. The perimeter of the shaded part, which is ADDC CB plus this arc here, is 64 cm. So first of all, we have to find what is the perimeter of the square ABCD. Okay, so since ABCD is a square, we know that AB is equal to BC is equal to CD and is equal to DA. So we can let the side of the square be X. and we can calculate the arc here, the arc length in terms of x. So the arc length AB is equal to half of the circumference of this circle. So it's equal to half times pi d. So that will be half times 22 over 7 times x. So we get the arc length as 11x over 7. And we know that the perimeter of x is 36 cm, and the perimeter of x is the arc length AB plus x. So we can now form an equation. So the arc length, which is 11x over 7 plus x, is equal to 36. So we add these two together, it will be 11x plus 7x over 7 is equal to 36. So 18x over 7 is equal to 36. So we have 18x is equal to 36 times 7, which is 252. So x in this case is just 252 divided by 18, and we have 14 cm. Okay, so now we come back to the diagram here. So each side is 14 cm, we can just put it in. Okay, so to find the perimeter of the square ABCD, okay, it will be just it will be just 4x, 4 times x, which is 4 times 14. We have 64 cm. Okay, now let's move on to part B. Okay, for part B, we want to find the area of the shaded part. So we can just find the area of the square minus of the area of the unshaded semicircle. That will give us the area of the shaded part, y. So the area of the square, it will be 14 times 14. This will give us 196 cm squared. Okay, then you can find the area of the semicircle, which is area of the unshaded part. Okay, this is half times pi times the radius square. Okay, the diameter of the circle here is 14 cm. So the radius will be divided by 2. So it should be 7 cm. So the area of the unshaded part is half times pi times r square, which is 7 square. So we should get 77 cm square. And the area of shaded part y, it is just 196 minus 77. We will get 119 cm squared. Okay, that's the answer. Okay, this figure shows a rectangular grass patch and an L-shaped footpath, and the width of the footpath is 100 cm as shown here, and the footpath is tiled using 38 circular tiles of diameter 50 cm, following the pattern shown in the diagram. So each tile is in contact with those next to it. Okay, so Question A, what is the area of the footpath that is not covered by the tiles? Okay, so we can see that the footpath is actually made out of a square with a circle inside, and the area that is not covered by the tiles is the shaded area here. Okay, so what we need to do, right, is to find the area of the square minus of the area of the circle to find the shaded area, and the total area not covered by the tiles, right, it will be the shaded area multiplied by 38. Okay, so we can proceed. Okay, first of all, we know that this length here is 100 cm. So that means the side of one square, it has to be 100 divided by 2. So we will have 50 cm. Okay, so the length of square is equal to 100 divided by 2, 50 cm, and the area of square, it will be 50 times 50. That will give us 2500 cm square. And we can find the radius of the circle as 50 divided by 2, 25 cm, and the area of circle is equal to pi r square, which is 3.14 times 25 square. That will give us 1962.5 cm squared. Okay, so the area of the shaded region, it will be 2500 minus 1962.5. With that, we will get 537.5 cm squared. And the total area that are not covered by the tiles, right, we have to multiply by 38 because they are altogether 38 tiles. Okay, so total area not covered by the tiles, it will be 537.5 multiplied by 38. Okay, we will get 20425 cm squared. Okay, that's the answer for part A. Okay, for part B, what is the perimeter of the grass patch? Okay, so the perimeter of the grass patch is indicated by my pencil marking here. Okay, so this question requires some logic thinking. So we have 38 circular tiles here. Okay, I want you to just focus on all the tiles except for this 4. Okay, so 38 tiles minus of 4, we will have 34. So 34 tiles are being laid here. You see a double layer, and then we have another double layer here. So I just want to focus on the layer that is beside the grass patch. So that with that, we will divide the number of tiles by 2. 34 divided by 2, that will be 17 tiles. Okay, so altogether there are 17 tiles that are right beside the side of the grass patch here. So which means that the length of the breadth here and the length here is equivalent to 17 times the diameter of each circle. Okay, so this is half the perimeter of the grass patch because it's the length, one length and one breadth. So we can say that half the perimeter of the grass patch is equal to 17 times 50 cm. That will give us 850 cm. So the actual perimeter of the grass patch, it should be 850 times 2. We will get 1700 cm. Here we have a symmetric figure that is drawn on a rectangular piece of paper that is 20 cm by 15 cm as shown here, 20 by 15. And its outline consists of a large semicircle followed by two smaller semicircles and two lines here. So to find the area of the figure, we need to find the area of the large semicircle. Then after we find the area of this rectangle underneath the large semicircle, and we minus off the area of these two unshaded semicircle. Then we add up these two shaded portions together, we can find the area of the figure. Okay, so before that we have to find out what is the radius of the large semicircle and the smaller semicircle. Okay, from this point to this point is 20 cm, so the diameter is 20, the radius should be 10 cm, and this side should be 10 cm as well. So if this is 10 cm, the radius of the smaller semicircle, it should be 10 divided by 2, so it should be 5 cm. Okay, so first of all, we can find out what is the area of the large semicircle. So it will be area of large semicircle. It will be half pi r squared. Half times 3.14 times 10 squared. We have 157 cm squared. Okay, next we want to find out what is this rectangle here. Okay, so it will be the area of rectangle below the large semicircle. This is 5 times 20. Okay, 5 cm times 20 cm here. Okay, so it's 100 cm squared, and the area of the two small semicircle, this will be 2 times half times pi r squared. So 2 times half times 3.14 times 5 squared. We will get the answer as 78.5 cm squared. Okay, and to find the area of this figure, it will be the area of the big semicircle plus the difference of these two. Okay, the rectangle minus of the area of the two unshaded semicircle. Okay, so you can answer the question now. Area of figure is equal to 157 plus 100 minus 78.5. With that, we will get 178.5 cm squared. Okay, so now we can look at the part B. What is its perimeter? So the perimeter, it will be the arc of this big semicircle followed by the radius 5 cm and the arc of these two semicircle here. Okay, so we can calculate it by this way. Perimeter is equal to half pi d pi times d, which is the diameter of the big semicircle, plus 2 times the arc of this semicircle, so it will be 2 times half times pi times the radius, which is 5 cm, and plus the two straight lines here, that will be 5 cm and 5 cm, so plus 2 times 5. Okay, so you work this out, it should be 31.4 plus 31.4 plus 10. So the answer is 72.8 cm. Okay, we have OPQRS is part of a circle with radius 10 cm. So we can label 10 cm here and 10 cm here. So OPR is a quarter circle, so this is 90 degrees. And OQS is also quarter circle, so this is 90 degrees. And the area of the shaded part is 40 cm square, and the perimeter of the shaded part is 28 cm. Okay, so now we want to find out what is the area of figure OPQRS corrected to 2 decimal places. So first of all, we need to find out what is the area of the unshaded portion OPQ and ORS. So what we can do, right, is to find the area of the quarter circle and we minus off the shaded area of 40 cm square. Okay, so area of quarter circle is equal to is equal to 1/4 times pi times r square, and the radius is 10, so it will be 10 square. So we will get 78.540 cm squared. Okay, so to find the area of the unshaded OPQ, what we can do is this: area of OPQ is equal to 78.540 minus the shaded area here, which is 40. So we will have 38.54 cm squared. Okay, since this area of OPQ is the same of the area of ORS because they are symmetrical, to find the area of the figure OPQRS, we just need to add this area plus this area and this area together. Okay, so the area of figure, it will be 38.54 plus 40 plus 38.54, and the answer that we get, it will be 117.08 cm squared. Okay, next we move on to find the parameter of the figure OPQRS. Okay, we know that the parameter of OQR is 28, and this is the radius, so this is 10 cm, this is 10 cm. So we can find what is the arc QR. Okay, so the arc QR is just 28 minus 10 minus 10. That will give us 8 cm. Okay, so we will indicate that QR is 8 cm. So how do we find arc PQ? Okay, we can find what is the arc of the quarter circle. Then we minus 8 cm, that will be the arc PQ. Okay, so continue. Arc of quarter circle, it will be 1/4 times pi d, and the diameter, it should be 2 times the radius, 10 times 2. So you work this out, you will get 15.708 cm, and the arc PQ in this case, it will be 15.708. Okay, 15.708 minus off this 8 cm, so we will get 15.708 minus 8, we have 7.708 cm. Okay, so what we have here is that this is PQ is 7.708 cm, and RS is also 7.708 cm. So the parameter of this figure is just 10 plus this plus this plus this plus this and plus 10. Okay, so now we can find the parameter. Is equal to 7.708 plus 8 plus 7.708 plus 10 plus 10. Okay, so we will get 43.42 cm. Okay, that's the answer.